On number 13, it says to find the distance between the two given points using the distance formula and using Pythagorean theorem. If your answer is a radical that contains a square root symbol, you have to simplify that radical. And we've practiced that on problems 7, 8, 9, and 10 already. So that's just a skill that you'll see over and over and over again. So the 2 points here, you want to make sure that if you're going to use your coordinate plane that you plot these correctly. So -6 means left 6, +3 means up 3. Here's my first point. 2, -5, right 2, down 5. Here's my other point here. Now, the distance between those 2 points is not going to be different depending on which formula you use. You're going to get the same distance if you do this correctly. So if you get different answers, at least one of them is wrong. You know that. Now notice down here I have the distance formula. That's because I will give you this on test day. You don't have to have the distance formula memorized. Now the distance formula is the square root of the difference in your x coordinates, and you're going to square that, plus the difference in your y coordinates, and you're going to square that. Okay, so you can go ahead and label this. If this is your first point, this is your x1 and that's your y1. If this is your second point, this is your x2 and your y2. Okay, so you're ready to use the distance formula between those 2 points. So your distance is equal to the square root of your second x, which is a 2, minus your first x. Now we know when we subtract a negative, you can put minus -6, but you know that's going to become positive. Subtracting a negative is the same thing as addition. So 2 minus -6 becomes 2 plus 6, and you're squaring that. Plus your second y, which is -5, minus your first y, which is 3, and you're going to square that. So now that you have everything in the right place, you just need to simplify that. So remember, do what's in parentheses first. So 2 plus 6 is 8, so 8 squared, plus -5 minus 3 is -8 squared. And so you have the exponents to do next. 8 squared is 64. -8 squared is also 64. That's always going to be positive when you square a number, because you're multiplying a number times itself. So a positive times a positive is positive, and a negative times a negative is positive. So you'll always get positive numbers here. Now you can add those and you get 128. Now 128 is not one of my perfect squares, but remember we have to simplify that radical. So if you need the factor pairs, you can go to your y equals, put in 128 divided by x, look at your table, and remember you're looking for perfect square factors. Okay, now 4 and 32, 4 is a perfect square, but that's not the biggest one, because 32 can still be separated into 4 times 8, 8 can still be separated into 4 times 2, so this is not the best one to use here. We can keep going here. 8 times 16, 16 is a perfect square, but 8 could still be separated into 4 times 2, so that's still not my biggest perfect square factor. So you could use those, you're just not finished once you get it into that, and there's 16 times 8 again. So I am looking for the largest perfect square factor. I may have missed it. I think I missed it. I didn't go back that far. There we go, right here. 2 times 64. It was way at the beginning. I just didn't have my table up there. I'm getting ink all over my screen there. But 2 times 64 is the way you want to go. 64 is a perfect square, and 2 doesn't have any perfect square factors in it besides 1. So we're going to separate 128 into 2 times 64. 64 is a perfect square. What number times itself is 64? 8. If you don't know, you know you can do square roots in your calculator. Square root of 64. Square root is above x squared, so you have to press the blue key to get it. So square root of 64 is 8. What's stuck under the radical? A 2. Okay, now remember, if you picked a different way, if you did 4 times 32 up here, you'd take the square root of 4 and bring it out as a 2. You just wouldn't be done at that point, because 32 has a perfect square factor. Let's say you separated 32 into 4 times 8. Square root of 4 is 2. There's a 2 out there it has to multiply by. You get 4 square roots of 8. You're still not done, because 8 can be written as 4 times 2. What's the square root of 4? 2. It has to multiply by the 4 out there and get an 8. And there you get 8 root 2. So you can still get to the simplified form. It just takes you longer. If you pick the largest perfect square factor to begin with, you do it in one step. So here's our distance between the 2 points. That was using the distance formula. Now we're going to use Pythagorean Theorem. Now remember, you can only use Pythagorean Theorem if you have a right triangle. So if we look at our coordinate plane, we can make a right triangle out of this by going from point to point on the grid lines, meaning go straight down and straight over. So we have a horizontal line and we have a vertical line. Those form a right angle when they intersect. The distance between the 2 points is represented by this segment, which becomes the hypotenuse of that right triangle. So our unknown distance is the C of Pythagorean Theorem. The A and the B values are your horizontal and vertical lines. You can find that distance by simply counting. So be careful here. There's 1, 2, 3, 4, 5, 6, 7, 8. So the length of that side is 8. We can count here. 1, 2, 3, 4, 5, 6, 7, 8. Also 8. Okay? You're not going to put any negative numbers here because these are side lengths. Side lengths have to be positive. So both sides have a length of 8. So now I'm ready to use the Pythagorean Theorem. I have leg squared, so 8 squared, plus the other leg squared, another 8 squared, equals the hypotenuse squared, which is my C value. I don't know what that is. That's what I'm trying to find. So 8 squared, 8 times 8 is 64, plus another 64 is my C squared. I can add 64 and 64 to get 128. And now I can undo the squaring by taking the square root of both sides. So now I'm to the exact same spot I was over here. My distance is the square root of 128. That's when we go through the simplifying of the radical again. So I can rewrite that as 2 times 64, take the square root of 64, and get 8 root 2 again for the distance between the 2 points.